All right, so let's get into the conversation of combining vectors. Vectors have many real-life applications, including situations involving force or velocity. So for example, consider the forces acting on a boat crossing a river. The boat's motor generates a force in one direction, and the current of the river generates a force in the other direction. Both forces are vectors, so we must take the magnitude and direction of each of them into account if we want to know where the boat will go. A second example that involves vectors is a quarterback throwing a football. The quarterback does not throw the ball parallel to the ground. Instead, he aims up into the air. So the velocity of this throw can be represented by a vector. If we know how hard he throws the ball, magnitude in this case is speed, and the angle, direction, we can tell how far the ball will travel down the field. And a real number is called a scalar in mathematics and physics. Unlike vectors, scalars are generally considered to have magnitude only, but no direction. That's the difference between speed and velocity. Multiplying a vector by a scalar changes the vector's magnitude, and that's called scalar multiplication. So let me actually write down that definition of the scalar. All right, so a real number is often called a scalar. All right, and so the idea is that a vector has magnitude and direction, but a scalar has magnitude, no direction. All right. Changing the magnitude of a vector does not indicate a change in its direction. For example, wind blowing from north to south might increase or decrease in speed while maintaining its direction from north to south. So just a note, which is that changes in magnitude does not automatically mean a change in direction. All right, so here's our definition then of scalar multiplication. So the product KV, and I'm noticing that the K here is not bolded, it's italics, right? And V is bolded and not italics. So our vector V is bolded and our scalar K is in italics. So the product, I'm going to use script for my italics, and I'm going to use the arrow for my bolding. So the product KV of a vector V and a scalar K is a vector with magnitude that is the absolute value of K times the magnitude of V. And with a direction that is the same as V if K is positive, and opposite is K if K is negative. Let me just kind of separate those terms. So direction is the same as V if K is positive, and opposite, right? So we're not just spinning around, we're either in the same direction or the complete opposite. Opposite the direction of V if K is negative. All right, this is called scalar multiplication. And if V is the zero vector or K is just the number 0, then either way their product is going to be 0. Awesome. All right. So let's look at some specifics, right? So if K is -1, then what that means is that when we compute this product against kv, we're taking the number -1 and multiplying it by our vector, which gives us the negative vector. So the negative vector is going to have the same magnitude, but the opposite direction. And we see that here in those notes on the right. So we have this instance of our length of our vector changing based on what number it is that we're multiplying it by. Let me just kind of sketch out those examples, right? So if this is our vector v, then 2v has twice the length, right? 1/2 v has half the length. And negative v has the same length, but a different direction. Awesome.